In this lesson, we'll begin our conversation on percents. So first off, the word percent is derived from a Latin term, per centum. Centum simply means 100. And so the idea of a percent is something out of 100. So whenever we talk about a percent, we're talking about some fraction out of 100. With that said, this is the classic percent symbol that you're used to seeing. And that symbol, every time you see it, you think of it as the fraction 1 over 100. So, let's take a look at this fraction, 35 over 100. Well, remember, over 100 just means percent. So when we see 35 over 100, all that means is 35%. That's it. Next example. Let's write the percent 50% as a fraction. Again, every time you see the percent, that simply means over 100. And that's all I want to say for that. Yes, you could reduce the fraction, but I don't want to go into that. Next example. We've got a figure here that's broken into 100 pieces. And so a percent can also be represented by a grid, where you have 100 parts in the grid, and the shading represents how many of them there are. As you might recall, this is another way that fractions are represented, and so we can look at it as a fraction out of 100, but that's again the same thing as a percent. So all we need to do is count up these shaded lines. Notice the shaded squares are 4 squares by 10 squares, so there are 40 shaded squares. Let's write that down. And that means that they represent 40%, since this is out of 100 squares. Alright, next thought is converting between decimals and percents. So whenever we see a decimal and a percent, we can really compare them by the fact that there is just a matter of 1 over 100. So, if a percent means 1 over 100, as a decimal that just means 0.01. So, to multiply by that means to multiply by 0.01, and this is where we get our rule. If you convert from a percent to a decimal, you move back 2 spaces. That's because the percent is like the numerator of the 100 fraction. So, if we think of it as a decimal, the decimal should be smaller than the percent. And again, we just move the decimal point back 2 spaces. On the flip side, if we want to take a decimal and write it as a percent, we'll do the opposite. We'll move the place forward 2 spaces. And remember to remove the percent symbol when you do this. So, quick example. Let's write 0.35 as a decimal. Or not as a decimal, as a percent. Well, all we have to do is move the decimal point up 2 places and add the percent symbol. Next example. Move the decimal point up 2 places and add the percent symbol. Pretty straightforward, right? Next one. Move the decimal place up 2 places. And this one is a decimal, but that's okay. We can say 87.1%. And then the final one, if I move the decimal place up 2 places, I need to include a new 0. So I get 10%. Alright, next example is the reverse. Let's take these percents and convert them to decimals. So remember, when you convert from a percent to a decimal, you should get a smaller number. So that might help you remember to move to the left 2 places. So for A, we're going to move 2 to the left and get 0.213. For B, we're going to move to the left 2 places, and that means we even need another extra 0. we get 0.006. With that said, when you see a percent that's less than 1, that's a very small number, 0.006. If you've ever heard anything like the odds are less than 1%, you know that means it's very little chance of happening. C. This time there is no decimal point written, but the starting point would be at the end. So if we move left 2 places, we get 1.75. And then D is the same thing. The decimal is implied to be at the end. So we get 0.85. A lot of the applications we're going to use have a percent written down, and we need to convert it to a decimal in order to actually do some of the arithmetic on these. So we'll use this in the future. Alright, next example. Savings account at a bank offers a rate of 0.01% on your account. And the question is, well, how much interest might you expect? This is actually a real example. This is the interest rate that Wells Fargo gives me on my savings account. 0.01%. So, how do we figure out how much interest we might expect? Well, let's write this as a fraction. But to do that, let me first write it as a decimal. So, 0.01%. Remember, whenever I switch from a percent to a decimal, I need to move the decimal point to the left. So, I get 0.0001. And by the way, note that that is 1 out of 10,000. So, the way that investments work is we'll get $1 interest for every $10,000 wow, in the account. Now look at that. You put $10,000 in the savings account and you only get $1 interest. And by the way, we'll talk about interest later, but that's probably every year you'll get the $1. It's a terrible interest rate. Alright, same bank offers a credit card with a 20% interest rate. So how much interest might you expect on that one? Well, I don't need to convert this one to a decimal. Let's just convert it straight to a fraction. So 20%, again, that's the same as 20 over 100. So here's what we'll say. We will pay, remember this is a credit card, we have to pay this interest. We'll pay $20 interest for every $100 spent on the credit card, or I'll say with the credit card. Boy. And by the way, if you put that on the $10,000 scale, you pay $2,000 interest for every $10,000 you spend. So savings account you can get $1, but the credit card you're going to pay $2,000. See where banks make their money? Working with unsuspecting people, offering them credit cards. Oh, I didn't write the word card. However, just so you know though, if you pay off a credit card at the end of every month when you use it, you don't pay any interest. Alright. Now let's talk about percents in a reasonable fashion. You are told that your employer wants to give you wants you to give 110% to your cause. You ever heard people say that? I want 110% from you. You should give 110% effort. Is this possible? Well, here's the idea. To give more than 100% is to give away more than one whole. Because though I haven't said this yet, 1 whole is 100%. So let's just say you can't give more than yourself. So this is a pretty good example of where numbers more than 100% make nonsense sometimes. Next, how about this one? The price of gasoline is 150% more than it was many years ago. And I don't know exactly how many years, but does this make sense to say 150% more? Absolutely. So to increase by 150% means you add on 1.5 times what you are now. So let's just do a quick example. Let's say gas was $1 a gallon. I want to say the last time I saw that was around the early 2000s, maybe even 1999. So gas was $1 a gallon, and it's now $2.50 a gallon. Notice that if you multiply 1 times 1.5, you get 1.5. If you add these two together, you get 2.5. And so it actually makes perfect sense to say that it has grown by 150%. So long story short, percents over 100 don't make sense when you're talking about giving or decreasing by more than 100%. But to add more than 100% makes perfect sense. It usually means very strong growth.